So the review for the first part of the Unit 5 test. So this is just over the first 3 learning targets. And I'm doing it as one video because these 3 are all connected with each other in one problem, one big problem. So they give me this table of data and they ask me to represent the data in a scatter plot and describe how the variables are related. Now you saw on my answer key, if you had noticed it, that these 2 columns were reversed. That's because I had gotten this from someone else and they had mean temperature first and elevation second. I don't know if they were trying to see if you guys were paying attention, but I went ahead and reversed it because the temperature depends on the elevation. The elevation does not depend on the temperature, so the independent variable should be our x and the dependent variable should be our y. Now, because it takes forever and it's very difficult to actually graph on this thing, especially when there's so many points, I went ahead and just scanned the graph that I had for my answer key. So I went through and I plotted all of these points. And I got the points in this configuration. Now, in addition to that, they asked me to draw a line of fit in a couple of sections. So my line of fit that I drew, I tried to, again, balance this so that I had roughly, and I was not counting the number of points on the left or the right of the line or above or below the line, but roughly the same amount on each side. And I felt that the way that I drew this line showed what I thought was the trend of this data for the slope. So this was the best line that I could figure out. Now, I ended up using one of my data points, and then this other point isn't a data point, but it is on the intersection of the grid lines, so I was able to then go down and find my x and y values. So, it said, what type of correlation do you see in the data? Be sure to use specific vocabulary in your answer. Well, it is a correlation because this doesn't look just like a scattered nothingness. I can actually see a pattern to this data, and a linear pattern at that. It's decreasing as it goes from left to right, so it's a negative correlation, and these points are all fairly close to my line of fit. They're not scattered all over the graph. So I ended up saying that it is a strong negative correlation. Again, it's a strong negative correlation because as the elevation increases, the mean temperature decreases, and the points are all reasonably linear. Now, write a sentence that describes the correlation in terms of real-world context, mean temperature versus elevation. I actually just said that. As the elevation increases, the mean temperature decreases. Then they asked me to draw the line of fit, which I actually did and already showed you, and calculate the slope of the line you drew. Well, I need to go back and find my 2 points that I used for my data, and I used the point 300 for x and 22 for y. And then I also used the point where x was 2,000 and y was 6. So when they ask me to find the slope of the line, I just have to remember that slope is rise over run. Take a second and say that to yourself in your head when you do these problems. Then you ask yourself which values rise on a graph. Well, my y's rise. And inside the ordered pair, y comes second. I have people who are actually doing well in this class overall who also, when they're in a hurry, are doing run over rise because they're rushing. They do the first thing over the second thing, and it's not. So my slope is rise over run. So it's the difference in my y's, my 22 minus 6, over the change in x, which is 300 minus 2,000. When I do that, I end up with 16 over negative 1,700, which can be reduced because they are both even. So it reduces to m equals negative 4 over 425. And the negative can go right in front of the fraction bar, or with the 4 or with the 425. But it is a negative answer. Now, all they wanted me to do in this box was to calculate. Now it says, what does the line slope mean? Well, if I think about it, the change in x, which is the bottom, is my change in elevation. The change in y, which is the numerator up here in the top, is my change in temperature. So really what it's saying is for every increase of 425 feet of elevation, the mean temperature goes down by 4 degrees Celsius. So as elevation increases by 425 feet, the mean temperature drops 4 degrees Celsius. Or you could say, as elevation decreases by 425 feet, the mean temperature rises 404 degrees Celsius. Either one would be fine. Now it wants me to find the y-intercept of the line. Well, I just found the slope is negative 4 over 425, and one of the points on my line is the point 322. I could use the other point, but the numbers are larger. I mean, instead of the 300, I'll be using a 2,000, so I chose to stay with the 300. I know the slope-intercept equation is y equals mx plus b. Inside this ordered pair, 22 is my y. My slope I just calculated is negative 4 over 425. The x from the same point I just got that y from is 300, and I'm trying to find the y-intercept, which is the variable b. So I end up with, well, let's just take this up here to get some room. 22 equals negative 2 and 14/17 plus b. By the time I multiply negative 4 over 425 times 300, so I'm going to add 2 and 14/17 to both sides to isolate the b and to move my constant with the other constant on the left, and I get b equals 24 and 14/17. And then it asks me to actually write the equation. So y equals negative 4 over 425. Make sure you're putting your x up here beside the fraction bar. Don't write it down here where it looks like it might be in the denominator with the 425. And then plus, because this is a positive, if it was a negative, I'd write a minus here instead, plus 24 and 14/17. Now, it asks me what the y-intercept means in terms of temperature and elevation. Let's go back to the graph and take a look at this. The y-intercept is this point up here at 24 and 14/17. And if that's where x is 0. So when the elevation is 0 miles, or I'm at sea level, my mean temperature is 24 and 14/17 degrees Celsius. So that's what it's asking. The mean temperature at sea level, which is 0 miles of elevation, is 24 and 14/17 degrees Celsius.